All right, so early on, you're gonna find out that we're gonna do a lot of reviews, some things that maybe you're already familiar with. Um, that'll quickly increase the things that are completely new to us. But I think a review is appropriate. It's good. If there's anything that doesn't make sense to you, let me know. Because I'm only teaching this one time during the day, if we come to class, say I give the first homework assignment, we come to class the next day, and we need to go over homework that takes us all the way through the entire period, I can do that. I don't have to stay with this class on schedule with somebody else. Does that make sense? So we can go at a pace that is conducive to all of us. Now, I do have plans, and I do have things that I want to get through, goals that I want to meet, and that kind of stuff. But if we have to spend an entire day going over homework, or maybe we come and say, hey, we did 1-3 yesterday, but I don't have a clue to what 1-3 was about. We can go over it again. I have the freedom, because we call it a singleton. We only teach it one time. We can do those types of things. Okay, so just make sure that you communicate that to me. One thing I tell my students all the time is I will never, unless maybe one of us, if you're wrong, I'm never gonna make fun of you for that. Okay, that's part of learning. I think you need to be wrong. Okay. I think it's appropriate to be wrong. If you are never wrong, no learning takes place, because you already know it, right? Does that make sense? Okay. So don't be afraid to voice what you think is the answer. And if it's wrong, I'll say, nah, try again, something like that. But I'll never just laugh at you because it's just a bizarre answer or whatever. Okay. And if anybody laughs at you because you're wrong, okay, and they're just kind of shaming you, let me know, okay? And then I'll have a talk with that person, and we'll get that fixed, okay? I would, in a class of, we got 9 people in here, I would rather have 9 wrong answers than one person give me the right answer all the time. Does that make sense? Okay? If I have 9 wrong answers, I know that I need to fix something. I need to go back and reteach something, correct? But if I get one person that answers the questions right every single time, and that allows class to move on, I know that one person is brilliant. They know what's going on. But the other 8 might not have a clue. But the class is still moving on because my questions are getting answered. Does that make sense? Okay. So the more feedback you can provide me, the better it is going to be for you. A lot of times, you obviously know your comfort level with the material and your knowledge of the material much better than I do, and much sooner than I do. If you know you have a problem, you know that much sooner than I do. Usually I find out that you have a problem when you have taken an assessment, when you've taken a quiz, or you've done a homework or a test, and you've bombed it. That's the indication to me usually then that you weren't comfortable with things, okay? Voice those thoughts, voice those ideas and opinions early on so we can address them, we can get them fixed. So when you get to a test or a quiz, you can breeze through them, okay? Does that make sense? All right. All right, so Chapter 1, like I said, a little bit of review. Chapter 1's called Expressions, Equations, Inequalities. Basically, it's a little bit of a review of going back and through and learning the types of equations that we've learned how to solve, how we address them, how we recognize patterns, and those types of things. Mathematics and algebra especially is kind of an analysis of patterns, okay, and being able to recognize patterns and being able to use those patterns then to what we call extrapolate, okay, means makes predictions, okay, for things that are going to happen in the future. And we'll see maybe some examples of that later on in these notes, probably tomorrow though, okay. Some key vocabulary words that we go through, okay, quantity, okay, is an amount of or measurement of an object, okay, that can be counted or measured, okay, so like your age, that's a quantity, okay. You're an object, and that is a measurement or an amount of that object, right? Does that make sense? Okay. Your weight, same way, okay. Height, all those things. Those are quantities, okay? Numerical values, essentially. Variable, okay? Symbol that is used to represent a variable quantity, okay? I don't know if I mentioned this the other day. I don't know if I mentioned it to you guys. I did mention it to one class. My daughter is in kindergarten right now, and she brought home work the other day. that looked like this. And she is doing algebra at the kindergarten level. You guys did this, okay? Because that box represents what should go there. 3, right? That box is a variable. You've been dealing with variables forever, okay? In 3rd grade, 2nd grade, kindergarten, whatever, you didn't call it X, but is it the same thing? Yeah, okay? That's what a variable is. It doesn't have to be a letter. It doesn't have to be anything specific in terms of the symbol we use, but it represents some unknown value, okay? So a symbol that is used to represent a variable quantity, so the symbol used is usually a lowercase letter and stands for a number. Like I said, doesn't have to be a lowercase letter, though sometimes we use, obviously, we're most accustomed to the English alphabet, okay, but sometimes we use like Greek letters. Sometimes, obviously, we use other symbols from other alphabets and that kind of stuff, but since we just don't know what the number is, and we often make the argument that the number is allowed to and is capable of changing, okay? So the word variable, what's it mean if something varies? It changes, okay? So when we call it a variable, that means that it's something that can and or does change, okay? Variable means a thing that varies, okay? An algebraic expression is a mathematical statement that includes at least one variable, okay? A numerical expression is a mathematical statement that includes numbers and operational symbols, but no variables. When we say operational symbols, do you guys know what the operations are? Good, okay? So when we talk about operational symbols, we're talking about adding, subtracting, multiplying, and dividing, okay? So you're going to hear me, I won't usually use those, I won't say add, subtract, multiply, divide, I'll just say what operation is happening here, okay? And then based on the symbols that we've learned in the past and the new symbols that we learned this year, you'll tell me it's one of those 4, okay? So if you think about it, all of mathematics and all of algebra kind of dwindles back down to just being able to add, okay? Because if I can add, if I go 2 plus 2, that's 4, right? 2 plus 2 plus 2 is 6, right? Okay. But 2 plus 2 plus 2 plus 2 is 8, right? Okay. But I can get to 8 quicker than saying 2 plus 2 plus 2 plus 2. I can go 2 times 4, right? Okay, because I added 2 4 times. So when we talk about multiplication is just a fancy way of saying it's repetitive addition. It's adding the same thing over and over again, right? Okay. You guys have heard that subtraction is adding the opposite, right? Okay, so if I want to subtract 2 minus 5, well, that's the same thing as 2 plus negative 5, okay? So it gives me negative 3. So subtraction is actually defined through addition. Multiplication, we just found out that was defined through addition. And we talk about division. Division is, think about this, adding and multiplying were linked, right? Multiplying was repetitive addition. So what do you think division should pair with? Say again? Not quite. Subtraction. Because so multiplication is repetitive addition. Division is repetitive subtraction. So if I say, let's say 12 divided by 4. We all know that to be 3, right? But where do I get to 3? If I start with 12, subtract 4 from it, what do you get? You get 8, right? Subtract 4 again. You get down to 4, right? Subtract 4 again, you get down to 0, right? And once I get to 0, or that I can't subtract 4 one more complete time, I'm done with the division, and I just subtracted 4 out of 12 3 times, right? So 12 divided by 4 gives me that 3, okay? So if you think about it, all the math that we've learned through adding, subtracting, multiplying, and dividing is simply based off our knowledge of how addition works, okay? And then everything else is built on top of that, okay? So we'll get probably through this example, and then I think the bell is going to ring at 2. Yeah. All right. So one of the key things for being able to operate within algebra, okay, whether it be algebra 1, algebra 2, college algebra, whatever, is our understanding, interpretation, and use of tables. Okay. So tables are a convenient way to organize data. Okay. Now, we could take data and we could just throw it in a table, but if there's no structure to the table, you're not going to be able to recognize a relationship, okay? So if I were, like right now, I've got these figures over here in the left-hand column listed 1, 2, 3, and then dot, 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 and that goes down to n, okay? Well, if I just had those as like, instead of in the, like, that's a structure, 1, 2, 3, that's a structure that we're used to. But if I went like 2, 1, 3, 5, 12, there's no structure to that order of those numbers, right? And I could talk about all the other columns, fill in the other information, but because there's no structure, there's no pattern, I'm not going to be able to recognize any new patterns, okay? And I'll explain that maybe if we have time when we're done with this specific example, okay? And that's what this paragraph goes on to talk about. It says the structure is often thought of as an input-output machine, or you'll hear me say the word rule, okay? What value am I going to input into a rule? And when I use that rule, and that rule is going to be an algebraic expression, okay? I'm going to add, subtract, multiply, divide, and then it's going to kick out a result, which we call the output, okay? So the rule takes on input values, processes it, and in parentheses I said does some operation on it. It could be a combination of operations, and then provides an associated output, okay? So the process column allows a good visual, provides a good visual for what the rule is that's taking place, okay? So just real quick, this one shouldn't be too difficult. If I look at this, we look at this. This is figure number 1 up here. So figure 1, how many toothpicks we got here? 4 toothpicks, right? So let's put 4 right there, okay? If I come down to number 2, how many toothpicks we got there? 8 toothpicks, right? Okay, so this is figure 2. Figure 3 here. How many toothpicks you got there? 12. Okay. Now, those 3 dots. Okay, if you're in English and you're writing a paper and you put 3 dots in, they're called ellipses, right? You guys ever heard that phrase before? Okay. Same thing happens in math. And basically it means that there's more information between 3 and n, but in math it says that information follows the same pattern that has already been expressed. So we see a pattern over there in 4, 8, 12, right? Okay. So if I would have a column or a cell of 4 for the figure number, then you could say, well, the next one's going to be 16, right? If I went 5, you could say the next one's going to be 20, okay? Because we can see that these ellipses show us that the pattern that is already established up here is going to continue all the way down through n, okay? So here's my question. What am I doing to this number to get that number? And there might be actually an infinite number of answers to that. But I'm going to ask then, is that then the same thing that you do to that number 2 to get the 8? Does that make sense? Okay. So some of you might have said, well, I could take this number here, 1, and add 3 to it, right? Does that make sense? Does that give me 4? Absolutely, it does. Okay. But if I take this number here, 2, and add 3 to it, do the exact same thing in the process column, does that give me 8? No. So that's not really what's going on here. That's not the rule that's happening. Does that make sense? Okay. So the rule has to be consistent from every single figure. Okay. So what am I doing to the 1 to get the 4 then? Multiplying by 4. So I'm taking 1 times 4. Is that the same rule then that's going on right here? Am I taking that number there and multiplying by 4 to get 8? What about right here? This 3 times 4, give me 12. Okay, so when I get down to that next column, or the next place to plug something in, where it's down there in that n row, okay, n is the number of figures, and what am I going to be multiplying it by? 4, does that make sense? Now you guys know algebraically that if I've got multiplication with variables here, where does the variable usually, where would we write it? Do we write it out in front like this? Now right at the back, right? Okay. So when I get to the nth object, okay, that's what we call this, the nth object, and then the nth figure, the number of toothpicks will be 4 times n. And when they ask you, you're going to see as we go through the rest of this tomorrow, there's going to be other examples in here that the relationship, the image, the picture shows different relationships. But if we can recognize that pattern in those 2 columns and see, what am I doing to that first number to get the second number? Okay, what am I doing in the first column to get the third column? And create what we call that process column in the middle. It's going to basically develop that rule or that machine that takes an input and changes it to an output. So when it says how many toothpicks, if the figure had 25 squares, this is what we call, lost my cursor there for a minute. Okay, we'll call it extrapolating, which basically means I'm not going to draw out 25 of these figures. I don't need to, okay? Right now the scenario says this is what happens for the first 3 figures, recognize a pattern, and now extrapolate or predict what's going to happen in the future. If you were to draw 25 of those squares out, how many toothpicks would you have? So n would be our 25. And if we're using that rule, then we've got 4 times 25, give me 100 toothpicks. Does that make sense? And we can get that result without having to take the tedious time of drawing that set of toothpicks out or laying them out if we actually had toothpicks in our hands. Okay? Does that kind of make sense? Is that pretty easy? All right. Tomorrow, bring that worksheet. We'll finish that up. Hopefully, we have codes and we can maybe knock out our first homework assignment after we get that done, but we will see. Okay. Remember, if you got any questions about anything, guys, email me. Don't hesitate to stop by when you get free time. We can always help.